In this example, we will find the exact value of each of the following, or state that it is undefined. The first one we are going to solve is arctangent of the square root of 3. We're going to approach these inverse trig questions in a very similar fashion as we did for arcsine and arccosine in a previous lesson. For arctangent, the first thing to keep in mind is the possible results that we can get, aka the range of arctangent. Arctangent of square root of 3 would have a possible range between negative pi halves and pi halves, which means no matter what, we have to get an angle measure within those values, and only one. We only get one answer. Now, arctangent compared to arcsine and arccosine may be a little bit less familiar to work with, so it is kind of recommended instead to think about it in terms of the angle measures you're more familiar with sine and cosine. What I mean by that is, remember that arctangent of square root of 3 is more or less asking the question, tangent of what angle measure, I'll represent with theta, is equal to the square root of 3. More specifically, tangent of what angle measure between negative pi halves and pi halves equals square root of 3. Well, tangent of theta we have from the quotient identity can be written as sine over cosine. So I can think about this as a ratio of sine over cosine. To go even a step beyond that, what I'm relating to the fraction of sine over cosine is itself currently not a fraction, but I can make it one. For example, the square root of 3 over 1. I can even go a step beyond that because I'm not very familiar, say if I just look at the numerator, with just sine equaling the square root of 3 and cosine equaling 1. But those values do look familiar. Normally, I see ratios of sine and cosine that are divided by 2. Like square root of 3 over 2, square root of 2 over 2, and 1 over 2. So, what I'm going to do is I'm going to consider that ratio of square root of 3 over 1, and I'm going to divide both the numerator and denominator by 2. I can do this as it doesn't change the value, since I'm doing the same thing to both the top and the bottom of the overall fraction. It's basically like I'm multiplying the top and bottom by 1/2. Doesn't change the value. But now, this may be a little bit more clear. I'm now trying to think about where sine of theta equals square root of 3 over 2, and where cosine of theta is equal to 1 over 2. That is a lot more familiar with me because I'm more familiar with sine and cosine values from the unit circle, not so much with tangent. The place between negative pi halves and pi halves, where sine is equal to positive root 3 over 2 and cosine is equal to positive 1 over 2, would lie in quadrant 1 and would happen to be the angle measure pi over 3. That is where sine is equal to square root of 3 over 2, and that is where cosine is equal to 1/2, and therefore that is where tangent is equal to square root of 3. Again, keep in mind, technically, sine can equal negative root 3 over 2, and cosine could equal negative 1 over 2, and that ratio would equal square root of 3. Tangent is also equal to square root of 3 in quadrant 4 at 4 pi thirds, but arctangent, which was the original question, can only result in an angle measure between negative pi halves and pi halves. If we had asked the question, where does tangent equal square root of 3, then there are multiple answers. But we're just asking the question, arctangent of square root of 3 is equal to what value? Let's apply that to the next problem. Arccotangent. It's pretty similar to arctangent. However, it does have a different range. Arccotangent, I'll write up in the top corner here. Arccotangent of negative square root of 3 has to result in an angle measure, not between negative pi halves and pi halves, but instead between 0 and pi. So that means in the unit circle, somewhere in quadrant 1 or quadrant 2. But we can still apply the same concepts to solve this problem. If I think about this as cotangent of theta is equal to the negative square root of 3, I can think about this as the ratio of cotangent for the quotient identity is cosine of theta over sine of theta. Then I can relate that, just like the previous question, to square root of 3 over 1. Or, more accurately, I can relate that to square root of 3 over 1, each of those divided by 2. The negative. I want to think about where cosine of theta is equal to root 3 over 2, and where sine of theta is equal to 1 over 2. The result being overall negative, so one of those would have to be negative. That happens not at angle measures of pi thirds like the previous question, but that happens at multiples of pi 6, such as pi 6, 5 pi 6, 7 pi 6, 11 pi 6, etc. Now we want this to be a negative ratio, so one of those would have to be negative. Since the angle measure has to lie between 0 and pi, if it's a negative ratio for cotangent, that would have to be from negative pi halves to pi halves, or somewhere in quadrant 2. So that's where, in this case, cosine would be negative in quadrant 2. So that means I want the angle measure in quadrant 2 that is a multiple of pi over 6, meaning my answer here is 5 pi over 6. Now, cotangent is a reciprocal function itself, or an inverse reciprocal, if you chose to try to evaluate this by thinking about tangent. So you try to do arc cotangent of negative square root of 3, and you try to think about this as arctangent of the reciprocal of the ratio, so negative 1 over square root of 3. You can do this. However, remember that arcotangent will give you something from 0 to pi, whereas arctangent will give you something from negative pi halves to pi halves. Since this is a negative ratio, arcotangent would expect an answer from pi halves to pi, whereas arctangent would give out an answer from negative pi halves to 0, because of the range restrictions on these functions. This is why these two are technically not equal to each other. But you can fix this if you add pi to your result from arctangent. Arctangent of negative 1 over root 3, that would give you negative pi over 6. And then if you add pi to that, you will get 5 pi over 6 back in return. Always remember what the original question was. This asked for arc cotangent, so we expect something in the range for arc cotangent. That's just an alternate way of dealing with that if you would like. For our last question, we have arc cosecant of 5 pi over 3. Do not fall into the trap that a lot of people do here. People see arc cosecant and cosecant and just want to go straight and cancel these functions out and say the answer is 5 pi over 3. But this is not true. You need to be careful about, just like in the previous question, the ranges of these functions. Cosecant of 5 pi thirds is fine. There's not really an issue there, but the original function on the outside is arc cosecant. And arc cosecant, if I scroll down a little bit, arc cosecant of some ratio has to result in an angle measure either between negative pi halves and 0 or between 0 and pi halves. we have that split because 0 is not a defined value for the range of arc cosecant. So, notice that 5 pi thirds is not within this range, so it cannot be a possibility. In cases like this, if it's not within the particular range, work from the inside out. So, evaluate the inside. Arc cosecant of cosecant of 5 pi thirds. Cosecant of 5 pi thirds will be the reciprocal of sine of 5 pi thirds. And sine of 5 pi thirds is negative root 3 over 2, so we're going to get negative 2 over root 3 from that. That's what cosecant of 5 pi thirds would be from the unit circle. Then, if I evaluate arc cosecant of negative 2 over root 3, you can go through that directly if you are comfortable with cosecant and secant, or if you'd like, you can change that into arc sine of the reciprocal of that ratio, so negative root 3 over 2. This is something you don't need to be too worried about when dealing with arc cosecant and arc secant as you are with arc cotangent, because they have nice overlapping ranges. For arc sine of negative root 3 over 2, again, has to be defined from negative pi halves to pi halves. Well, that would have to be within the quadrant 4 range of this. Arc sine is available for quadrant 1 and quadrant 4. Since it's a negative ratio, it would have to be quadrant 4. It would have to be an angle measure where sine is equal to negative root 3 over 2. Within the range of negative pi halves to pi halves, that would happen at negative pi over 3. That would fit within the range of negative pi halves to pi halves. So that answer is good. You may notice that this answer ends up being a coterminal angle measure to the one that was provided, 5 pi thirds. That's not always going to be the case. Sometimes the angle measure on the inside of these kinds of problems is perfectly fine, is within the range of the inverse function you're working with. If so, great. Then they do cancel out pretty nicely. But if it's not within that range, you need to work from the inside out and work carefully.